Question 6. The function f is defined by fx is equal to x times the square root of 1 minus x squared, where x lies between -1 and +1. The graph of y equals fx is shown below, right? And show that, part A asks, show that f is an odd function. Okay, so for this, we're going to have to use the definition of an odd function, which I'll write down for you, which is f of -x is equal to negative fx, right? And additionally, we can sort of see that it's fx does look like an odd function because an odd function has rotational symmetry about the origin. So here, of 180 degrees or pi radians. So we can see that if we sort of copy our graph, let's paste an image here. We can see if we rotate it around half, we have the same function. So it certainly looks like an odd function, but we're going to have to confirm that that is the case. All right, so let's highlight our important info. Let's take the function itself, the domain, and we'll say odd function here. Okay, so to start us off, let's talk about, so an odd function is, as I said, is when if f of negative x is equal to negative fx, then that means we have an odd function. Okay, equally, I'm going to write in as well what an even function would be, just because it's worth knowing. All right, and that is f of negative x is equal to f of x. All right, so that's a bit of bonus. Just an extra bit. So we don't need that. So to show that we have an odd function here, I'm going to have to show that f of negative x is equal to negative fx. Well, f of negative x is essentially we're just going to be lobbing in negative x for x in our function here. So we're going to get negative x times by the square root of 1 subtract negative x squared. And this has to equal negative f of x. So for this one, we're going to just put a negative sign at the start of the function and then sort of lob it into some brackets. And 1 minus x squared. Okay, so now looking at the left-hand side here, we've got negative x in brackets at the start, so we can just sort of take that out of the brackets. And then what you have to sort of identify is that negative x squared is just going to equal x squared, right? Because negative times negative is positive, so that's just going to be x squared. So we get 1 minus x squared under our square root sign. And now we look at the right-hand side, we're going to get negative x, all right, and then just multiplied by, I'm going to be somewhat lazy and just take this, just multiplied by the square root of 1 minus x squared. And there we can see they are the same function, all right, so therefore we'll conclude that these equal, so f of x is an odd function. Cool. And there is the answer to part A. Okay, on to part B. And so we are told that the range of f is A is less than y, which is less than b. So the range of f is between A and B. A and B are elements of real numbers, and we're asked to find the value of A and B. So let's look at the graph that we have visually and kind of illustrate what we're going to be finding. Okay, so if we zoom in here and we go from this minimum point here, all right, that means this minimum point here, this is going to have to represent, this y value is going to have to represent A, because we're told that that was the minimum value of f. And also this maximum, this maximum value, let's go up here, this maximum value is going to have to be equal to b. Right. Now we're also told that the graph of f here lies between -1 and +1. So we can sort of note that this must be -1 over here. This must be +1 over here. I'll give it a little top and a hat. Okay, so the corresponding x values for this minimum here and the maximum here will have to be, the absolute value of that will have to be less than 1. Okay, and so how about we also note then that the corresponding x value for when y is equal to a, or when fx is equal to a. Let's say we can call this x underscore a, and same idea for the b one. Let's bring this down and let's call this x underscore b. All right, and so what you essentially need to identify here is that the gradient at the minimum, or at the turning point, so the minimum point and the maximum point, will be equal to 0. Both of their gradients, are equal to 0. And so if we take the first derivative of our function f and find when that's equal to 0, that will help us find the xa and xb, so the corresponding x values for the value of a and the value of b. We'll take them and plug that into our function f, and then that will give us our values of a and b. Equally, towards the end, I'll note as well, since we found in part A that this is an odd function, we won't need to plug in xa and xb into our function f. We'll just need to find, do one of them, and then we can use the fact that this is an odd function to find the corresponding value. All right, we'll get to that in a bit. All right, so let's copy down. Let's copy down our diagram. Let's copy this down. Let's take it a slightly nicer picture. Let's copy that. We'll go to a new page. Let's bring that there, and we'll say part B. And so we're trying to find the values of A and B, and fx is equal to x multiplied by the square root of 1 minus x squared. So now, in order to differentiate our function f here, we're going to need the product rule and also the chain rule, okay? Since, the fx is the product of two separate functions, first function being just x itself, and the second function being the square root of 1 minus x squared. And then in order to differentiate that bit, square root of 1 minus x squared, we're going to have to use the chain rule. All right, so let's go over to our formula booklet and find these rules, which I've somewhat conveniently got here. Let's bring these over. That's the one. All right, so these are the rules that we're going to have to apply. Okay, so let's go through, and so let's just look at the product rule for now. So when y is equal to uv, the derivative of y is u multiplied by the derivative of, or dv dx plus v multiplied by the derivative of du dx. Okay, so sometimes this is looked at as, I know this is technically a little bit, I know the u dash idea is only really, or using dashes for derivatives is only really applicable for functions. So I like to sort of visualize it like that. So u dash v plus uv dash. And also one thing I wanted to note here is that the order in which you do these doesn't matter, since we are adding them together. So the order only really matters for the quotient rule. All right. So let's have a look at this and let's apply these rules. Okay. So if we have, so we'll say u is equal to just x, our function here, and we'll say v, so that v looks almost like a u, is the square root of 1 minus x squared. Now I'm going to rewrite this, so v is in surd form here. Now I'm going to rewrite this in exponent form, which makes it easier to differentiate. Right, so that is going to be 1 minus x squared to the power of a half. Okay, this is because the indice law, or the indice law is the square root of, let me clean that up a bit. in fact, we'll write it here. The square root of k is equal to k to the power of a half. All right. If you're not familiar with your indice laws, I would recommend brushing up on it. You just sort of Google indice laws. You'll probably get a whole bunch that pop up. Yeah, which would be worth knowing. Okay. So first of all, let's just work on, let's find the derivative of u, which is relatively straightforward. The derivative of x itself, derived with respect to x, is just 1. Okay, so we'll put that there. And then now, if we want to find dv dx, now you can go, so essentially if you look at this, the rule or the formula that you're given in your formula booklet sometimes can lead to some confusion. What it's essentially saying is that if y is equal to g of u, where u is its own function of x, then dy dx is equal to dy du times by du dx. Now that works, and obviously it's obviously correct. The way I prefer to potentially look at it is you cover up what's within your bracket here and just differentiate around the bracket. Okay, basically as if the bracket's its own sort of term, or it's like it's an x term, right? So if I'm doing that, then this is going to be, well, bring the half to the front. Okay, then you put what's within the bracket just down here, so 1 minus x squared, untouched. All right, and then we, as per normal, subtract 1 from the subtract 1 from the power. So then we get negative a half. Okay, and then the next step is to then just multiply by the derivative within the bracket. Okay, so you derive the bracket as a whole and then multiply by the derivative within the bracket, right? And the derivative within this bracket is going to be negative 2x, okay? Because derivative of 1 minus x squared will be negative 2x. So we'll put times by minus 2x, right? Now we can clean this up a bit and put it back into surd form, which will help us later on. So let's put this, we're going to say this is equal to, well, something else. And yeah, I'll take a couple steps here. So it's going to be 1 over 2, actually, beg your pardon, let's call it just 1 over 2 multiplied by the square root of 1 minus x squared. So I've essentially done this rule in green over here in reverse. And then we're also going to have to then times by negative 2x. And we'll see that the 2 here and the 2 here can cancel out, right? And so then we can say we are left with, I'm just going to make this slightly smaller. Let's go there. We will be left with negative x over the square root of 1 minus x squared. And beg your pardon, that's not put a square there. 1 minus x squared. Let's clean it up a bit. 1 minus x squared. Okay, great. So now we have du dx, which is equal to 1. We have dv dx, which is equal to negative x over the square root of 1 minus x squared. So therefore, the first derivative of x is equal to, so u dash v, or u times by dv dx, or whichever way around you want to do it. The order doesn't matter in here. So we're going to say x multiplied by dv dx, which is here. So I'm just going to sort of lob that into a big bracket. All right, and then I can add on v multiplied by du dx, which is just 1, so it's just going to be v. So we can just bring, this over here, bring this down there. All right, cool. And then if we want to clean this up a little bit, we can say that, let's say we've got negative x squared on the top over the square root of 1 minus x squared. Let's just copy this, bring that there. plus then the square root of 1 minus x squared. Okay, and then now we're going to have to find the x values that make this equal to 0. All right, and those x values will be xa and xb as shown in our little diagram up here. Okay, so what we can do from here is we can say that let's bring our x squared to the, let's say here, let's add the equivalent of this. So hold on, let me just change this into, where's my blue colors gone? We'll go into this. All right, we'll say we'll add this to both sides. Okay, and then so essentially our right hand side is going to turn into, so therefore the square root of 1 minus x squared will equal x squared over 1 minus, or the square root of 1 minus x squared. Okay, and then now what we can do is we can multiply both sides by, we could say here, and let's bring this over so it's slightly more central. Okay, and now we can multiply both sides by the square root of 1 minus x squared. So let's say times by the square root of 1 minus x squared. I wonder if I can change the style to the colors that I like. No, it doesn't really matter. All right. Okay, and so then if we do that, times both sides by the square root of 1 minus x squared, we're going to get, the square root of 1 minus x squared times by the square root of 1 minus x squared will just be 1 minus x squared. All right, so we'll get that on the left-hand side here, 1 minus x squared. And then that's essentially going to cancel out the denominator on our right-hand side. So this is going to be equal to x squared. All right, then now if we add x squared to both sides, okay, we're going to get just 1 by itself on the left-hand side, and then we're going to get 2 lots of x squared on the right-hand side. Okay, and then we can sort of say, therefore, then, we can divide by 2 from both sides. Let's do that. We'll say divide 2 from both sides, and we can, we're going to say we get a half is equal to x squared. Okay, and then we'll take the square root of both sides. All right, and then that's going to give us, so this is where a lot of errors sort of come in. So the square root of a half is equal to plus and minus the, plus and minus the square root of a half. Squared will be a half. All right, so we get the answer being plus and minus the square root of a half, which is the same as just saying 1 over the square root of 2. And then this is equal to x. And we need a new page, so let's bring this down. All right, so that means therefore xa is equal to negative 1 over the square root of 2, and xb is equal to 1 over the square root of 2. Check this. All right, now let's say if we lob in either one of these into our function f. So let's lob in a is equal to f of xa, which is going to be equal to, so fx was negative 1 over the square root of 2 multiplied by the square root of 1 minus x squared, so which is going to be negative 1 over the square root of 2 squared. All right, now if we go through and work this out, we're going to get negative a half, negative well, that's going to be negative 1 over the square root of 2 multiplied by 1 minus, so this is just going to be a half. Let's bring this there, and so this is equal to negative 1 over the square root of 2 multiplied by the square root of essentially a half, which we know is 1 over the square root of 2. And this just equals negative a half. All right, so then therefore, a is equal to negative a half, beg your pardon. And now, since we know that f is an odd function, so of course what you could do also here is lob in xb into our function f, and that will give us the value of b, which would be absolutely fine. Though what we can also, we could sort of skip a bit of a step here and go back to sort of the idea that in part A we found that f of x is an odd function, right? And so we could sort of say, since f of is an odd function, then f of negative 1 over the square root of 2 will equal negative of 1 over the square root of 2. All right. Now we already found that this here was equal to a. So that one was equal to a. Now this is essentially saying this here, this would be what we would use to find the value of b. Then this is essentially saying that a is equal to the value of negative b. And so then we can conclude that therefore b is equal to a half. Okay, and then that is the answer to part B.